Orphan Red, long time no habla.
Hey, Jeranism. How are you?
Good, you?
Oh, I'm doing well.
Good. So explain what you mean. Where does mainstream science say it moves faster?
Okay, so I don't want you to think that I'm plugging my own content, but so I'm just
That's
sharing
okay.
a link.
That's kind of the point of this. It's okay to do that here.
But I shared a link with you in the chat, in the private chat. So I made this video so long ago, and it didn't really get much notice. But when I actually did the research, I found that the standard model, they do say that because the sun is off center in their globe model, the speed of the Earth at its orbit orbits the sun fastest when the Earth is near to the sun, which is in our winter months. So even if you just, I started the video at 15 seconds in.
Okay.
So even if you just freeze and read that, that is actually what the standard model claims, that because the Earth is orbiting the sun on an elliptical orbit, as it swings closer to the sun, it goes faster, right? And so then the sun moves across our sky faster in our winter. Does that make sense?
Yes. Is that the equivalent, though, of saying that the sun moves faster in the southern summer? Yes, right?
Yes.
It would have to be. So according to the standard model, as the Earth moves around the sun, which sits off-center in the ellipse of the Earth's orbit, if you choose a point on the Earth today that faces directly towards the center of the sun, solar noon, it will take 24 hours plus 4 minutes for that point to be back facing the center of the sun again. Okay, I get it. Is it 24 hours plus 4 minutes though?
Yes, that's the
sidereal.
Yeah, sidereal day versus the solar day. There's a 4 minute difference.
Yeah, but the sidereal day is 23:56. So anyway, I'll keep going. It will take 24 hours 4 minutes. So I could see it to get back. It's going to need extra time.
That's correct.
Would it need 8 more minutes though, or yeah?
No, it just takes 4 more minutes.
So then it would be 24, not 24:4. Because a sidereal day is 23:56, right? Pretty sure. I'll just look.
I thought it was 24 hours and 4 minutes, but I could be wrong on this. I made this video, I don't know how many years ago, 6 years ago?
Yeah, see, so sidereal day is 23 hours, 56 minutes, and 4.9 seconds. This is called a sidereal day because in THTT time, what the fuck is that? The stars appear to complete one revolution. Wikipedia, sidereal time is... I'll have to think about that one because I know what you're saying, to completely come back to the same point.
Because it's moving...
Yeah, because it's moving in a circle.
Like it would depend, right? Like if it's moving, let's say, forward with the sun, then it has to rotate a little bit further to come back towards the sun. But when it's moving away from the sun... Okay, but...
No, it's always the same. It would always be the same. Okay, let me read this real quick. So
yeah.
Let's not... Yeah, that part's not important. But for that point to be facing back to the center of the sun again tomorrow. Because in those 24 hours, the Earth has moved relative to the sun, and because the sun is off-center in the standard globe model, the speed of the... And when you say off-center, what do you mean by that?
So if you look at that little picture in the bottom right-hand corner,
okay,
the standard model doesn't actually put the sun in the center of our solar system.
Right, the very center would be there.
Slightly off,
right?
They say because of Jupiter's mass or whatever, that there's...
Right.
The focal point is slightly off-center.
So, and does that mean that the sun orbits that centerpiece?
I haven't seen them claiming that, but they would have to.
They would have to. Yeah,
but they do say that the elliptical order or the elliptical orbit over 100,000 years changes and becomes more circular and then more elliptical as well, right?
So I see what you have here. You have an elliptical orbit, but when you say, because you say the Earth is off-center, that's what part confused me. The Earth is moving around, and because this... Oh, you said the sun is off-center. Okay, got you. In the standard globe model, the speed of the Earth as it orbits the sun is faster when the Earth is near the sun. Correct. Okay, so it gets near here. That would be when it's angled. I'm sorry, it gets up because it's near, it's faster, and then it goes slower. Okay. So I guess, yeah, it would move faster in the sky. And because the sun is off-center of the standard globe model, the speed of the Earth as it orbits the sun is faster when the Earth is near the sun, which happens in our winter months, right? Like January, than when the Earth is farther, as it is in July. So the Earth orbit rotates faster in October to April, and then it slows down. This is why sundials fall out of sync with our watches by up to 7.7 minutes. In April, our watches are 7.7 minutes ahead of the sun, and in October, our watches are 7.7 minutes behind. As the sun is rushing much faster across our sky than our clocks are running. That's incredible. I mean,
Isn't that incredible? And it was so hard for me to find this. And if you look at this diagram, I lifted this directly from peer-reviewed research article about this phenomenon, the diurnal day length. It's yeah, and I found it was such an obscure paper, like on page 187.
yeah, because it's devastating. It's kind of devastating to them.
It is. Yeah, it is. And it supports the flat earth model because what it suggests that because the sun would need a different amount of time to go to circle a larger circle in the southern.
And it gets confusing because people can just say, well, it still takes 15 degrees an hour. And you're like, yes, but 15 degrees covers more area if it's a larger circle. Right?
It's that it actually covers more. So if you look at this graph, so this is from the peer-reviewed research article on the diurnal, like the day length, something or other.
Okay.
And so you can see how in March and April and May, the sun is traveling slower across the sky than in September, October, and November. That's what we would expect.
Wait.
On a flat Earth.
Slow
because
sun.
when the sun
gotcha. In the summer, yes.
Because in the sun in October and November, it's circling down much closer to Antarctica.
Mm-hmm.
So it has to go across a much larger, what's the English word that I'm looking for? Circumference.
Correct.
And then in the months in March and April, then it's closer to the Arctic. So, right?
Yeah. I guess the part that is bugging.
I'm so incoherent. I'm so sorry. It's because I just had a really, really busy, cognitively draining day. So like,
no, it's no problem. I mean, and I'm thinking, this is the thing when I'm trying to think off, I don't have any time to actually consider, but it's funny because they always have to have some answer. Right.
Yes.
And so I've never heard them address this, which I thought kind of meant they didn't have an answer. But now I'm thinking about their answer and I'm like, God, I can see why Globers would believe that. What I mean is that it's always hard to find that gotcha that the explanation doesn't fit their model. Their model explanation is exactly what you already showed with the sun going faster when it's closer. And now it's almost, because I've always wondered, why do they tell us that the sun is closer in our winter? It never made any sense to me. But now it makes sense because it has to be.
That's why they had to do that.
Yep.
Because it's the only way they can explain it.
This is why I did this show. See, this is awesome. Now I know. I'm writing this down. So now I know why they say the sun moves faster. Or the sun is closer. Sorry, the sun is closer to Earth
in the winter
in our winter
hemisphere,
which makes no sense. But it's measurable.
If you hit play, but yeah, keep it muted.
Okay.
And we move to the next bit. Yeah, so this is where I was just showing that.
Correct.
In my own little unique way.
The princess goes around. Yes.
Right. She's the.
Can I ask, how do you do this?
Oh, I just Photoshop.
Okay. Like images, and then you make a bunch of them?
Yeah.
Okay.
Yeah, and then when I bring them
well, that's how I do it too, which is kind of long.
It's a long way of doing it. And then I bring it into Premiere, and then I make it so that it's a little bit better. But yeah, no, I suck at. I know there's an easier way of doing this.
I'm sure there is too, but I'm not good at animation and stuff like this. So yeah, this is the. Now I don't know if you've seen this too, but one thing I've tried to get people to do is, I would love for somebody in Australia, here on the West Coast, to film a sunset at the height of summer, and then one at the, in the height of winter, and do the same thing from the north, because I guarantee that their sun, when it sets, since it's moving so fast, it's very quick.
Yes.
Whereas for me, when the sun sets from California, I bet you it's much slower, and this is why we have so much twilight here.
And the California, Australia would be a good comparison because I think they have similar enough climates.
Yeah, because they're both at about 35 degrees. Well, actually, Australia it would have to be. This is not correct where you have it drawn, but it would be a little bit more up here, because I know. For me, this is not. You don't have the equator drawn, but yeah, for me, obviously, I'm higher than that, and I'm at 37. So Okay. Yep. It makes sense. It would have to be much faster. I wonder if Dave knows that. I've never heard Dave mention it.
I don't think honestly, I don't think anyone knows,
Right.
because I put this video out back in, when did it? Oh, actually, May 2018. Okay, so May 2018, that was like, not to bring up sensitive topics, but that was like after I was outcast from the community.
It's for all the porn
And
videos you're doing porns with Mark. That's what you know.
I
I'm
don't,
just kidding.
I've never done porn.
I'm kidding.
But so, but yeah, but the thing is, it was so hard to find this data. So the data is there, but it seems as though, like, even the Google search algorithm, they really try hard to hide it. They really bury it deep down in the search results. So you do have to look up diurnal length, I think was the keyword that I ended up stumbling upon, that maybe.
Well, it's so weird too, and this is where I get lost and I kind of like tune out. Is so our clocks are what? Let's say we've got a analog clock, and
Yes.
it's 24 hours, and it goes back to midnight. And 24 hours is midnight, but the day is actually 23:56. So you're saying that basically it falls behind 7 minutes and then ahead 7 minutes, but only as compared to the sun.
Only as compared to the sun. So those are two different phenomena. Because the 4 minutes, that explains why 6 months later
Correct.
they can say that this noon isn't happening in the middle of the night, right?
Correct.
So if you count all those 4 minutes, but that's different from the sundial 7 minutes. What's happening there is that the sun is moving across the sky at a different speed, and so then your sundial, the shadow of your sundial, is moving at a different speed in the winter months versus the summer months, because the speed of the sun is different. But your clock has the same speed of rotation all the time. Doesn't matter if it's winter or summer, your watch is always spinning at the same speed. So that's why the sundial falls ahead and behind your wristwatch, because it's based on the speed of the shadow.
Huh.
Right?
Yeah. Is that what they call the equation of time, or is it something different? What's the equation of time?
I don't know.
It's just something I've heard him talk about, and then I've looked at it, and it seems entirely impossible to understand, but it's pretty important, I think, to see. It's kind of got the same graph here. So the equation of time describes the discrepancy between two kinds of solar time.
Okay.
The word equation is used. The word equation is used in the medieval sense of reconcile a difference. The two times that differ are the apparent solar time, which directly tracks there you go with the diurnal motion, which is an astronomical term referring to the apparent motion of celestial objects around Earth, or more precisely around two celestial poles, over the course of one day. It is caused by Earth's rotation around its axis, so almost every star appears to follow a circular arc path. Okay. Of the sun, a mean solar time which tracks a theoretical mean sun with uniform motion along a celestial equator. Apparent solar time can be obtained by measurement of the current position, hour angle of the sun.
Right.
As
That makes
indicated
sense.
with limited accuracy by a sundial. Mean solar time for the same place would be the time indicated by a steady clock set, so that over the year its differences from apparent solar time would have a mean of 0, which it must eventually.
I think that's what we're talking about, isn't it?
Yeah, it's basically saying that, and they're just not saying it the way we want them to say it.
Why? And here it is saying the obliquity of the ecliptic.
The plane of the Earth's annual orbital motion around the sun, which is inclined 23.44 degrees relative to the plane of the Earth's equator, the eccentricity of so these are the two things we know about. Okay.
But see, they're not talking about the sun being slightly off center.
Well, the eccentricity of the Earth's orbit around the sun would be caused by the sun not being in the center, right?
Oh, yes, because they're saying it's 0.0167. Yeah, okay,
right.
That makes sense.
So the equation of time is constant only for a planet with 0 axial tilt and 0 orbital eccentricity, which doesn't exist. I would think that goes against Kepler's laws, doesn't it? Two examples.
It would be a perfect circle. It would be a perfectly circular orbit.
Well, this says 2 examples of planets with large equations of time. Oh, okay. I thought it was saying no equation of time. On Mars, the difference between sundial time and clock time can be as much as 50 minutes. What?
Okay, so then that means that the sun moves through the Martian sky
A difference of 50, significantly 50.
faster in the winter versus the summer.
Weird. Due to the considerably greater eccentricity of its orbit, the planet Uranus, which has an extremely large axial tilt, has an equation of time that makes its days start and finish several hours earlier or later, depending on where it is in its orbit.
Weird. But see, again, this is kind of make believe, though.
Obviously, but they have to. If it happens to the Earth, they have to apply it to the other planets, which may make them ridiculous.
Well, so first they make up what orbit has to match our observation, let's say, of Mars moving through our sky, and then however that orbit works out to match the motion we see, then they have to come up with this crazy way of like, okay, well then how fast is the sun moving across the sky on Mars?
Right.
And that's where they're coming up with this like, 15-minute difference, right? So they're always working backwards.
That's crazy. I'm just wondering, why wouldn't like Jupiter and Saturn be even worse? They have bigger orbits. I guess they could say it's not as eccentric. It doesn't matter on the size
of the orbit. What matters is on how elliptical it is.
How elliptical, right? Okay.
And that is governed by how it looks from Earth, how it moves in our sky, governs what kind of weird ass orbit they pretend that it has.
Yeah, it's so funny too, because when you think, it's like, I'm just thinking about all the tests and experiments they supposedly did in the 16 and 1700s when they only had pendulum clocks.
Yes.
It's like we're supposed to believe that Galileo is measuring the time for things to fall down from, and he's got a pendulum clock. It's not like he's got a stopwatch or something.
And there's a lot of Russian research done on pendulums, and there's a whole host of problems with that. And under the eclipse, they exhibit all kinds of anomalous behavior.
Plus, I'm sure that pressure changes them. I'm sure depending on your atmospheric pressure, your barometric pressure, I'm sure there's all kind of time of year, whether it's hot or cold. All those things would change a pendulum.
Definitely, and humidity, because you're thinking, okay, if they're using a pendulum made of wood, and what kind of string are they using, right? So
is the string expanding? Is it a metal string? Is the metal string expanding? Is it contracting?
Like their measurements were very, very rough and approximate, and then now we pretend that using their really poor instruments, somehow all their math matches what our model says today.
Yeah, and then like here down here, it's like the irregular daily movement of the sun was known to the Babylonians, but it's like that to me. I'm like, well, wait a second. Don't you have to have a clock to know that?
Well, that's the thing. They would not have been able to have a precise clock. All they would have had is the sundial, which, like we just saw, they're admitting that the sundial, the speed of time changes.
So I guess that's something that could have been noticed by an ancient people if they had sundials, and then they just noticed that this is weird. The sun doesn't take the same amount of time.
But how would you know? You'd have to have
something
comparison to, right? Like you could say objectively or subjectively, I feel like the day is longer, but you wouldn't have anything to measure against.
No. And so if I take my analog clock and I go out every day exactly at noon on the analog clock, is that what creates the analemma then?
Yes. Oh, that's interesting.
So that's the going back and forth. That's the going too far and then coming back.
That would be affected by...
So yeah, I mean, this is part of the analemma. So the reason the analemma has the fat bottom...
Yes.
...is because the sun obviously moves more, quicker, faster. If it was the same in the north and the south, then the analemma would be a infinity sign. But since it's moving faster in the south, it makes a bigger loop in our camera.
That's it. That's an interesting observation. I have to think about that.
I got to think about it too. I'm writing it down. Okay. I just want to finish reading this. So Ptolemy discusses the correction needed to convert the meridian crossing of the sun to mean solar time and takes into consideration the non-uniform motion of the sun along the ecliptic. He states the maximum correction is 8 1/3 time degrees, or 5/9 of an hour. What?
What is?
It says Ptolemy discusses the correction needed to convert the meridian crossing of the sun, which would be where it crosses exactly your meridian.
Okay.
Which should be noon, but isn't going to be noon. It's going to be plus or minus.
Right. Okay.
To mean solar time, and takes into consideration the non-uniform motion of the sun along the ecliptic and the meridian correction for the sun's ecliptic longitude. He states the maximum correction is 8 1/3 time degrees. I've never heard of time degrees.
Either have I.
or 5/9 of an hour. Book 3, Chapter 9. However, he did not consider the effect to be relevant for most calculations since it was negligible for the slow-moving luminaries and only applied it for the fastest-moving luminary, the moon. Based on his discussion on the Almagest, values for the equation of time were standard for the tables in the works of the medieval Islamic
But
astronomers.
see, that's the problem with this, is that even if he's taking into account corrections based on where he believes himself to be, right, away from the equator,
Mm-hmm.
he's not taking into account the difference in the speed of time. Like, I'm saying the speed of time, but I mean like the speed of the sun across the sky, obviously, right? But like, he's not taking into account the difference in the speed of time between winter and summer. So all these calculations that he's done very precisely
Are all they're all fake.
They're all fake because
Yeah.
if you're measuring the motion.
Yeah, the whole that's where science crumbles for me, and that's where because I've tried to believe in this shit, and what happens is you go back and you look and you realize it's just a story because none of the things lead to the next. They do if you tell a story backwards, but when you try and follow along, it doesn't work.
I wonder if we're onto something here in terms of discovering the nature of the stars and how they're moving and, you know, the firmament, dome, whatever, because the stars would have a similar relationship, right? As the stars move up. Do you kind of know where I'm going? I'm sorry, I'm really incoherent, but I'm trying to just kind of think this out before I say it because I don't want to say.
Yeah, I guess it's kind of weird because they say everything to do with the stars moving would be just the Earth spinning, and then the stars do move, so they have to say then that the tilt moves.
But so on a flat Earth, then the stars also have to circumscribe a larger circumference as they move, as they're observed in a more southerly.
Correct.
location.
Sure.
So then we should see a change in the rate at which.
Well, but the southern stars are always the southern stars for us, right?
No, but aren't there there are some that like Orion is visible in the north for some parts of the year, right? But not in other parts of the year. So could we not look at the speed of the stars moving through the sky in March, April versus October, November and see if there's a difference? Because if there is a difference, then that means it has nothing to do.
This is great. You're right. And you know what? This is why they want us to use not linear time, but they want us to use radians.
Yes.
So they want to get away from the idea of actual time of doing an orbit, because when you do that is when you would expose it. But by saying 15 degrees an hour, that's always correct.
Yeah. So
by saying 1 rotation per day, that's always correct.
Yeah. And I also think that's why they make so much emphasis on, our new cesium clock is measuring the second to, 100.
How about this? The equation of time has a range of 33 minutes.
Oh, that's cute.
All right, well, look into this. I got another person waiting, and come back and talk to me or write me. I think I messaged you last time on Twitter, and
yeah, sorry about that little I was locked out thing. But yeah, I'm gonna look into this because I think we're onto something in terms of proving whether or not the stars are moving across a flat Earth sky or whether the Earth is rotating in a universe of stars. I think this would maybe prove either one.
Sweet. All right. Get back to me.
Okay, thank you, Jeranism. Have a good night.
Later.